All right, good morning, sixth graders. Um, Today we're going to start off with a little do now. I want you to pause the video and calculate the density of a liquid that has a mass of 235 grams and a volume of 50 milliliters. Go ahead and pause. All right, so I'm going to show you how I calculate this, and you can double check your answer. I'm going to use a calculator for this one because I know it doesn't divide perfectly. I know that density is mass over volume, and I know that the volume of this substance is the mass of this substance is 235 grams. The volume is 50 milliliters. So I am going to do 235 divided by 50. I got 4.7, and the units for that, I'm actually going to write that out. So the units for that are grams per milliliter. So the reason that it's grams per milliliter is because we divided grams by milliliters. So we're actually just going to leave those units with the mass divided by the volume units. So 4.7 grams per milliliter. That's how you would write that. All right. Today's lesson is PS7, Pure Substances and Mixtures. Remember that you can pause the video at any time if you need a little bit more time to write things down. The first vocab word, sorry, I should have labeled all the next four things as vocabulary. So this is vocabulary. Elements. Pure substances that cannot be separated into simpler substance by physical or chemical means. So this is when we've looked up at the periodic table in our classroom. This is what we're talking about. Everything listed on the periodic table is an element. So some that you've definitely heard of are oxygen, carbon. You've probably heard of hydrogen and helium, neon, which is in those neon signs. That's actually that's an element. Silver is an element. Gold is an element. Those are all considered elements. All right, molecules are they're a pure substance, and they're composed of two or more I want to change that. Two or more atoms bonded together. So they're a pure substance composed of two or more atoms bonded together. I think this is actually easier if we can look at a picture. So we're going to do that. Let's see if there's anything good here. All right, perfect. So here we have an atom. That's just like a single little unit of matter. A molecule is two or more of those units of matter, two or more atoms bonded together. So we could have like four atoms bonded together and we would still call it a molecule. So this is a compound, which we're going to talk about next. A compound is also a form of molecule. See how there's three atoms bonded together? That counts as a molecule because there's more than one atom bonded together. All right, let's go back here. Next up, compounds. This is a pure substance composed of two or more different elements. So in order to be considered a compound and not just a molecule, it has to have different types of elements bonded together. Take a second to think about, what is H2O? If you said water, you are correct. H2O is water. That is a compound because we have hydrogen atoms bonded to an oxygen atom. We can tell that they're bonded together because all the letters are smushed together as one thing. There's no plus sign between them, no arrow between them. This is one thing all together, and it's called a compound, and it's also a molecule. I wonder if you guys know this one. Think about this for a sec. Have you ever seen this before? CO2. I'm sure some of you have. If you were thinking carbon dioxide, you are correct. Again, this is a compound because we have carbon bonded to two atoms of oxygen. And then this one we talked about, I guess that was 2 weeks ago with, what's his name? Albert? was in the class with us, NaCl is salt, which maybe some of you knew. Yeah, and that's a compound because we have two different atoms bonded together. All right, last vocab word, mixtures. This is a combination of two or more pure substances that are not chemically combined. I think one of the easiest mixtures to think about is salt water. In salt water, the salt and the water molecules are not bonded together. They're all mixed together, but they're not bonded together. So that makes them a mixture, and they are not a pure substance. All right, so this is a lot of vocabulary, and this would be way easier, I think, to understand in person, but we're going to keep working through this online stuff. So I'm going to show you a bunch of examples because I think that's the best way to start to get more comfortable with this. And I wanted to recap one more thing. Okay, so pure substances versus mixtures. This is how we're going to think of these things. The pure substances are any elements, any molecules, any compounds. Those all three count as a pure substance. Then separately, we have mixtures, which is when you mix any of those things together. Most of the stuff that we see in the world is a mixture. Yeah, we are mostly looking at things that are chemically mixed but not chemically combined. That said, of course, we also see a lot of compounds and a lot of elements. So we're going to look at some examples now. All right, I'm going to show you a bunch of pictures. I want you to pause the video and think, actually maybe you don't have to pause, I'll just wait 5 seconds. I want you to try and save the identity before I can get to it. All right, so first you're thinking about rocks. Are they pure substances or mixtures? I want you to look at all these different rocks in this picture. These are mixtures, those are different things. Copper, is that a pure substance or a mixture? Copper is a pure substance. It is actually an element on the periodic table, so it's not a molecule or a compound, it's just an element, which does make it a pure substance, and its abbreviation on the periodic table is Cu. All right, pure substance or mixture, jelly beans. That is a mixture. This one's tough. Is this a pure substance or a mixture? We're talking about sugar here. And when we say table sugar, we just mean like regular sugar. I'm going to give you a hint. I'm going to show you this. Hopefully that shows you something more about this. Okay, so looking at this, we know that table sugar is not an element. It has 3 elements in it, but it is not a single element itself. So then we also see that since it has 3 different elements in it, we know that it's a compound. And we know that it's a compound because, again, there are no plus symbols, there are no arrows in it. This counts as a compound because all those elements are chemically combined. We can tell because they're all right next to each other. So that is a pure substance because all compounds are pure substances unless they're mixed with other compounds. Diamond. This is another tough one, I think. Pure substance or mixture. So this is a pure substance. Diamonds are actually just made of carbon, which is really interesting. Is this a pure substance or a mixture? Check out that there's this tea is not like black tea. This has some milk in it. Oh, that one didn't give an answer. Ah! Oh, I just gave one away. Okay, tea is a mixture. All right, salt. Hopefully you didn't see the answer already. I did talk about this one in the examples. This is a pure substance. It is a compound. Salt is not an element, but it is a compound made of 2 different elements. Neon gas. I also mentioned this one. I wonder if anybody remembers. This is a pure substance. It is an element. All right, salad. Pure substance or mixture? Oops. Yeah, this one is a mixture. We can see different leaves mixed in there. All right, pure water. That one kind of gives it away, right? Pure water is H2O. It is a compound. which makes it a pure substance. Aluminum. If you thought it was a pure substance, you were correct. The abbreviation for this on the periodic table is Al. It is an element. Lemonade. Lemonade is a mixture. If you've made lemonade before, you know that you just like you either stir like some powder into water, or you use some lemon juice and some sugar. So you're mixing those things together and they're not chemically combining. All right, sand. Sand is a mixture. Silver. Silver is an element, which makes it a pure substance. All right, those are all the examples I have for you. After you've taken notes on this stuff, I would suggest that you also add examples to your notes. I think this is a lot easier to think of through examples. So go back and add some examples to your notes. And then you are going to do a short reading, and then you are going to fill out a Google form with answers. If you have any questions, please email me and we can chat this afternoon if you want. All right. Hope you had a good weekend. Talk to you later.